All right. Hey, sorry for this technical interruption. We had a little camera problem, but I think now it seems to be working fine. So, welcome to Decentral Live number 13. This is Raz. We will work on S19 Gen board. I got like three or four of them, and we had many questions. Some people had many questions about those on our Discord channel. So let's answer to them today, and let's hope to repair and have some victory today too. So let's start. I have 1, 2, 3, 4 to work with those. Starting, if we start with that one here. Good. It was a little bit last minute. It's right now. It's 1 p.m. 1 p.m. and 1/4. We usually do some lives later during the day, but hey, let's change the habit a little bit. So this one, it's gonna be J Pro S19AL S19J Pro NP. So it seems to be S19J. 2, 3, 4, 5. We can recognize it with the 5 MOSFETs, and we can also, if we are making a chip count, if you're doing, we got them right here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 120, 1, 2, 3, 4, 5, 126. So it's definitely the J Pro that I can select right here, and I got 126 right here. Okay, so first thing, we will take some notes on those. Do I have a pen somewhere? Yes. Yes. J Pro 126. Let's see the problem of that one. Okay. Because I will work on S19, I will move my arc tester if possible, just to have a better angle. But you know, no, let's keep it like that. Hey, Amilcar. Hey, man. How's it going? So if we start those one, J Pro. It's been a while since I've worked on S19. I've worked on L3 Plus for quite a while and S17 Plus. So last time, the last live I was doing, the live number 12, I was working on S17 Plus on very hard Hashboard. And surprisingly, yesterday I was able to bring one back to life. So completely recovering. 65 chips, stem sensor are fine, and we did all the tests. I was actually putting back all the heat sinks. But yeah, let's take a break on S17 Plus and let's work on J Pro. Just maybe I don't remember by heart for the voltage, so let me take a look at my notes. document, or maybe do you remember S19J Pro, the voltage?
Isn't it 12.6?
It's 12.6.
I believe so, yeah.
So yes, we're live. Okay, so that one maybe we don't see it on the computer, but I have a J. Oh, it's just a regular J. It's 13.6 volts. So let's do that because my arc tester is telling me the frequency, and also the voltage,
Peux-tu
the working voltage.
peux-tu tester en attendant l'adresse
So I
reçue
got my
pour
tester, negative, positive. It's 21 right now because it was working on 17 gen. So let's drop my power supply at 13.6. There we go, right on it. Hola, Gabriel. How's it going? And let's play. Boom. Let's see the behavior. Is the voltage okay? Zero chip found, but the current is stable. It's not going straight to 10 amps. Temperature sensor here. So let's take some values. I hope that you see the here should be good. Okay, so what is going on with those one? I'm always starting with last domain and maybe the booster right here. So I got my 21 volts, so my booster is working because if I'm comparing to the regular voltage, it's 13. So voltage is fine. I got power into the hashboard. And if I want to take values, so you see, I will step that because it's heating quite fast. I got my camera right here. Let me adjust my light. Yes. What if I am adjusting it like that? Sorry, I still need to get used to it. I'm always saying that, but it's not my desk. So, and also a microscope eventually will be much better. Okay, so you see, I got my 5 testing points. So if you want to take your values, most of the time on the 17 gen, you can go directly on the chip and then measure with your multimeter onto the testing point. But that one is going to be either this side or this side. Both of them are going to give you different values. So take the one that is the closest to the official value that you're supposed to have. So if we're comparing most of the time the voltage value, it will be pretty much the same than a 17 gen. So you got your LDOs are still 1.8, 0.8. I still got my return signal that's going to be 1.8, CI reset also. Different, one of the things that's going to be different is going to be the clock signal. So on to 17 gen, it's going to be around 0.8, but on those one it's between 0.7 and 1.4. So if I am taking a value right here, I will take my, if I want to take my voltage, I just want to be sure, yes, it's gonna be the last one right here. So if I want to take my clock, oh, my clock values, it's gonna be here, and now it's 0. So maybe because the board is not working, so obviously something's going on. But if I'm going, by example, to those ones, if I want to take values, so this is going to be the first, second, third one. So third one going to be the testing point right here. Oh, let me zoom. There you go. So I got my first chip and then clock and 0.6, and if I'm going to the other one it's 0.9, so that will be the good measurement will be that one, because if then I'm going to, oh, that one is my main camera. So if I'm going here, oh, now my voltage is dropping. It's not that bad. If I'm going here, I will measure my clock. Oh, 0.1, 0.5. So now I don't have enough power to work on. I need to wait for it to cool down a little bit. So that one, I will let it cool down. I will mark my work. 0.86. Next. Mm, yeah, there you go. So you see right here, you got all your values. So if I want to have my values, I will either check this side or that side. As I said, I don't remember it by heart. So when, if I am powering up the dashboard, I will take the value from either one of this side, and then if I'm looking to the sense, so the wave, it's going here and then going up this side. So that chip, if I want to measure the clock, it's always the chip and then the testing point here. But if I want to measure the return signal, it's going to be the chip here and then my return signal right here. So if you're working on some Bitmain hashboard, return signal is always in the reverse from the other one. So we'll take here. So we'll take that measure. So if I want to measure the clock from the BI reset, you know, it's going to be like this. So it's pretty simple. It's literally written on the dashboard. But if you want to let's see for the LDO. So if you want to measure the LDO, you can measure them on the other side. If I'm showing you the LDO on those ones, it's gonna be on that side here. So you see where it's written U86 and so on. So all those will be the LDO. So you can measure directly, same thing as 17 Gen with one of the heatsink, that's going to be your ground, and then one of the pins of the LDO if you want to have your measurement. But from the other side, S19 Gen is you got two bonus testing point. On a regular 17 Gen, that's going to show you the 5 same as the other one, but two more. One is 1V8 and 0V8. That's going to be your LDO values. On those hashboard, it's going to be pretty much the same thing as a 17 Gen if you want to measure them. Let's just see when I will do my when I will put power on the dashboard, if it's going to be those two little here. Here, most of the time it's going to be those two here. But yeah, let's see. So again, we are working on S19. If you got any question about those, it's going to be a good time for it. Otherwise, we still have our Discord channel that you can ask question about mining. That could be a good thing too if you're not live with us. But you know, don't be shy. It's always good to have a good interaction. So that one, if I'm still counting, 1, 2, 3, 10, it's gonna be a J also, or a J Pro. J Pro. Hmm. Where are my notes? Here. All right, number 2. Same thing, 13.6 volt. Okay, that one. Still zero ASIC. Temp sensor are all here, so that's fine. Let's measure booster. Oh, I got 0. Let's see if there's power in the dashboard. Yes, so I got power in the dashboard, but oh, we don't see that much. Well, can I wait? Hold on. We don't see a clear difference. Sorry about that. Let's work. Because one of you guys told us that we in another live you didn't see quite well enough the values into the multimeter. So let's hope that time is gonna be a little bit better. Okay. So that one I directly have a problem with the booster. Some work has been done on that one from another technician, but I don't think he's here for the week. So let's see if we can make that happen. No parts are missing. Okay, let's do some test. So again, I got the power. I got power into the dashboard, but oh, now I got power. Maybe I wasn't well enough on it. So now my booster is working. If I'm measuring return signal, 0.7 and 1 and 1. Oh, reverse here. It's gonna be 1 and 1. on all. So the last chip is lacking power. Or I have power, but the return signal is problematic. Again, if I'm still measuring, my booster is working fine. It was just a bad measurement. So that could means that the last chip might have problems. So let's take a look at the diode values. Do I have okay. Mm-hmm. Let's start with clock 0.7, 0.788. Already that clock signal is weak. Let's measure from other chips. 0.7. Let's measure a little bit earlier. So maybe S19 and S19J have different diode values. Seems like it. Let me take a look at my notes. Trying to find all the info that we have on those. Okay, yeah, 126 chips. Booster is at least 20 volts, so that's fine. From the boost circuit, U238. Hmm. Hmm. 15 volt. Yeah, okay. Oh, hey man. So is the view a little bit better? So let's see. Again, voltage value. 323. 324. 322. So that one has complete different values from the other ones. Do I have any signs of damage? Seems not. So what we'll do, I'll try to change the last chip to see if it's gonna make any difference. Or if we are following the signal and I measure a little bit after. Yeah, absolutely. But those one, let's see what's the matter now. I want to see. Oh, okay, 2.5. Because what's strange is that my return signal is a little bit strange, and all my diode values seems all the same from across the board. So the diode values are different from S19 and S19 Pro. I could change the last one because the last one start with my return signal and is 1.1 instead of 1.8. But there's some other parts. There's one. It's supposed to be one chip closer here. If I am doing that here, I think it's this one. I will go back to my notes, but I think this one is the return signal conversion chip. And this is what I want to take a look at. So RX. So return signal is going from last chip to first chip and return to the signal cable terminal through U1. Is this U1 or I think yes, it's closest to the I/O port. I just found it and it's a completely different part. It's the small part
Yeah,
that I've changed on the iPad.
yeah, it's a small crystal. It has
Yes.
six pins.
Do we have some other for those ones?
I think so. Let's just see.
So I'm taking, how am I measuring it? I'm always, because now I have voltage. I don't have a direct voltage from the power supply, but I have 3.3 volt or 3.2 volt from the tester. So this is why I am measuring right now, and I can have some values. For example, with those ones, I get to 2.6, but it's a strange value. I will need to check with another board. 33. Oh, nice. So we got some of them here. Those are very smaller than 17 gen, so it's gonna be a little bit more tedious to work. But again, we got some here that would be available on our shop. If they are not listed, you can always make a custom quote, and we can check about those. So let's go back on that one. I just want to see if I got any values before working on those because they can break pretty easily. Well, I would just want here. Ow. Oh, oh, interesting fact. I don't have any power, but with the arc tester plugged on, it's super hot. I can't even I cannot even put my finger on it. So that's strange. So that will actually indicate a problem. Yep, U1 is burning hot. Did you know about that one?
Well, for if there's a short, for sure
Yeah.
it's gonna give up.
So that will confirm that it's not necessarily the chips, but that might be that small part. So that will be my first attempt to repair that one. Oh, but
We
just
got some
before,
questions.
yeah, we got some question. I used to heat up chips from under with T17. Is it safe to do that with S19 as well? Well, yeah, actually, it's a very good way to do it. I've seen some people making like a hole, like a 6-inch hole or 4-inch hole for your heat gun to go under. Some people are liking it. So yeah, that's actually it's not dangerous at all, and it can sometimes be more safe because instead of having all the heat directly on your chip, it will be spread across the board, so it will be a little bit you have less possibility to damage your chip. But those can take quite a heat. So so you can try on them, but under them is a very good way to do that too. Same thing with 17 Gen or even a L3 Plus or a S9. It doesn't really matter. You just need to be careful where you heat and not heat too much, so all your other heat sinks will fall out. But those one can take heat. So yeah, it's absolutely safe to do that with S19 as well. How do you feel about heat from under? So yeah, I'm not quite used to it because I don't have a straight hole on my desk. So sometimes I need to go a little bit on the side. But you know, it's just a question of habit. Because I get much better solder ball when I go from under and also don't risk to moving resistance and other component. There's that too. So you actually have your own guess. So that's a good way to make repairs. What do you use for air volume strange when you solder? What do you use for air volume strange when you solder? Most of the time, I'm using most of the time depends on the rework station that you have. I have a A10 SMD rework station ST 862D, super reliable, super nice to work with, and I'm using 470 degrees and 55% of air when I want to take out heat sinks and chips. Sometimes chips, when I want to take them off, that I know that the chip is broken, I am just stripping it with the same heat. But if I want to put another one on, I will just reduce my air a little bit at like maybe 40 or 35%. And also the rework station, I found out that those uh, those bended no, yeah
Nozzle.
yeah nozzle those bended nozzle are very useful because you can have a good angle and just where the how the heat is spreaded. Very nice machine to work with. So yeah, so let's try that one.
Questions. We have heat tape both align ports for this one.
Heat tape. Thank you. So you know that one, maybe I will try to work from under for that one, but just before I will try to apply maybe some heat resistant tape. I don't know if I can take it under. Let's see what I can do. Hmm, do I have some scissors? Yes, baby scissors. So what I try to do, I try to floss it under the I/O port, between the dashboard and the I/O port. But you know it's sticky, so it's quite hard. No, you know what? It's not gonna work from that side. So let's try from this side. Yeah, I got that same heat gun. Very nice. Very good machine. What is the issue? Well, we're here to find out. So, Nathaniel, the issue, what I think it is that small part right here. So you will see quite soon what I mean by that is the U1, because not the U2, U1. First thing is my return signal is weak. It's 1.1 instead of 1.8. And also when I am plugging just the just the tester from the I/O port, it's burning hot. So I will try to take it out. Let's use some zoom in. There you go. This. There we go. Let's try with my third eye. Alrighty. So you see that one I will need to go. I will try to hit from under. Should be nice. Let's use some flux. And, oh, but before that, let's clean that. So what I want to test, because it's a very small piece, I want to see where the writing goes. Yeah, I should have took notes. Okay, so the writing is down here. So what you can do, you can try to see with the writing, but if I am going closer, you have, okay, let's stop to touch it. Huh. So you see the writing right here, but there's also that small dot, and I got another one here. So that small dot will indicate that's gonna be on this side. Um, where did I put them? I had them 3 seconds ago. The small part that I had 3 seconds ago. Okay, it's here. It's so small. Okay, so that would be on that side. Okay, there you go. One, two, three. Let's prepare one. Perfect. So now I can apply some flux. And because I'm heating from under, I will go to about 470. and 55% of air. So that one maybe I can try to close the vent. It's gonna be more stable. Huh, it's just not working. Okay. It can take a lot of heat. It's starting. I'm seeing melting on the other side. There you go. So you see 6 very small pin. From under, is everything all right? Yeah, everything seems fine. Now let's try to put that one back. A little bit of flux as always. I will take my small part here. Okay. So what I will try to do, because that part is very sensible, oh you, I will try to apply heat before applying the part, because those one are way more fragile. Starting to heat, so there's 2, 3, 4, 5, 6. There you go. So I don't know if you saw, but what I was counting was the melting of the six testing point. Not testing point. I mean just the six ground point of the part. What's the issue? Could you show what point you will use to short the signal to find breakpoint of signal? You show what point you will use to short the return signal or the arrow signal to find the breakpoint of signal, like when you got zero ASIC.
I think
Why?
he's looking for where to short the 1.8. You know, when you want
But
one.
it's the same thing as when you want one ASIC missing.
Yeah, yeah, exactly. But I think he's asking like, are you taking from 1.8 to the RX, you know, to short to
Yeah?
find the.
But where is the 1.8? Maybe.
Yeah, exactly.
Yeah,
I think so.
yeah. Yeah, sure. I will test it after that. What do you hit under to remove the U1? Because so there's many things about that one. First thing, the uh, yeah, let's remove that. It's gonna be more serious. First thing, there's many sensible part here. IO port is more fragile to heat than the other parts, so I don't want to heat directly in that section and risk to burn it. Also, that part is more fragile and also is so small that the amount of heat and the amount of air, so 55% might be a little bit too powerful for that part. And because it's actually like the third time that I'm taking those one out, and I don't want it to fall off or go or all the other part to fall off. So just in case, I was eating from under, so that it will spread a little bit better. And uh, yeah, that's pretty much about it. So instead, I was protecting the part under. So you see that tape, so thermo resistant tape can resist up to like 450 degrees of heat. It can take a little bit more, so you see it's still not completely damaged or melted, so that was fine. So I was protecting those the IO port connectors, because those one, if they're heating too much, the heat will go up to the IO port and it can burn it too. So you need to be careful with those. I was also trying to protect those ones because those ones, if I'm heating from under, they got a high risk of melting and desolder or bad soldering afterwards. So, but if I was to, if I was putting thermal resistant tape on the IO port, for example, all like that. Maybe I could have tried to heat it from the upper side. By example, like that. That could have worked too. So let's use this one. The melting seems fine. We will let it cool down a little bit. Hey, monkey! What voltage? Hey, many people today. What voltage and current do you set your power supply to test the J Pro with the arc tester for finding zero ASIC? Zero ASIC or all ASIC, it's the same. It's gonna be the same power. So nice things about the arc tester is that it's showing you which type of board and the voltage on it. So those one is 13.6.
The power supply on the left side.
But if you're using the power supply, like the lab or the Antminer power supply, it's recommended to be 15 because it will
5. 5.
15 amps.
Non, ouais, c'est ça fait c'est 13,6 volts, puis c'est un lab de power supply de lab de 15 ampères.
Oh, okay, got it. So if you got, by example, my power supply that I'm using is a 30 volt 10 amps. I'm using 13.6 volt on the J Pro. But if you got, like, by example, a lab power supply that can go higher in the current, that is recommended to try to go to 15 amp, but with the same voltage. So I hope it answering your question. But I don't have a personally for testing. I'm using 13 volt and 10 amps, and all the testing are going super fine. If I'm going here, all the chips, and just try to find in my notes if there's something else. Meanwhile, it's cooling down. But I am testing them at 13.6. But what you can also do, you can test them to 15 volt, because in the machine it's going to be tested at 15. There you go, that one. Oh, sorry, just change the camera. No, if what you can do for your tests, you can check the type of power supply that the machine is using. If it's, by example, if APW3, APW9, APW12, those can have different range of working. By example, APW9 that are on the 17 gen,
Yep.
APW9 17 gen, they're working between 21
14 volts.
and 14 volt. Yeah, so you can try to make some tests. Most of the time 17 gen we're testing them with the same power supply, 21 volt, but because the miner, when it's making its test, it's starting at 20 in the machine. When you're before mining, when the machine, you can take a look into the kernel log, you can see that it's starting at the 21 volt, going down to a 20, 19, up to the working voltage of the hashboard. So those ones, because my working voltage is 13.6, but the APW12 is starting at 15, I will, if I want to make 100% full test that I know that this board is working, I'm gonna finish my test with 15, because sometimes it's gonna work at 13.6, but maybe at 15 it will have problems, and it need to work. So yeah, you can work into those range, but most of the time work a little bit lower when you are working on them, because the more voltage you're putting on them, the more current you have too, and the more heat you're gonna get from those ones. So your testing is gonna be more difficult. So yeah, pretty much it. So let's take a look at the part that I've changed, if there's still the same problem, and after that we're gonna try to see for the jumping method. Okay, that one should be cool enough. So let's see. JPro. So do I still have heat? Because if I still have heat, that would mean that the problem is definitely somewhere else. Or if I don't have heat, maybe my part well placed, is my part that I changed damage. I don't think it will be damaged, but might be a false soldering, or maybe the part is fine. So doesn't seems to move. I use the power bench and it maxes out at 10 amps. So yeah, you see, when I was testing that one with the 30 volt and 10 amps maximum, when I'm testing, it was about 6 amp. But we see many times those maxing out the 10 amps, but still working into the miner. Okay, let's test those ones. This voltage on. So you see I am 13.61. I got my tester is fine, 126. Still 0.6, sadly. But let's take a look at the power. 13 volt, so power is coming in. Booster 21 volt, so booster is working. And now, same thing, sadly. 0.1. Is that part still working? 3.3. So let's try to change the last chip. Hmm. Do I have a marker? Nah. Okay. Never mind. So last one here, 1, 2, 3. Last one here, 1, 2, 3. So when I want to take it off, I'm using those bended tweezers, and I will just pry a little bit to the other heatsink. There you go. Or maybe before that might not necessarily be the U1 that might be the problem. Might be maybe a resistance before that, or a capacitor. Because I got the same values. That's really, really strange. So let's take some values on those ones. Wait, bon, there you go. Here, here. So let's try to take some values. Working voltage. And suppose here. Something that is different here. Earlier I was at 2.7 but now I am at 3.3, so that's a good thing. 3.3, 3.3, 3.3, everything's fine. And that part is not hot anymore. And I still got, right after that, I still got 3.3, 3.3. 1.5 should be fine. Okay, now let's measure resistance. Thirty-three, 0.1, 0.998. Okay, and that one, even if there's no resistance, sometimes can give values. There you go, 10. Oh, maybe I'm too much. That one is a little bit more strange. 34. 0.99, okay, that one's fine. That should be fine. So again, what I am doing here, why I am in diode mode inversing, it's just for the good, it's just for a good value. So when you try to have voltage values, you're doing your negative on the ground and your positive on the testing point. But if you want your diode values, it's going to be reverse mode. So you're positive on the ground and you're negative on the testing point. I want to see return signal. 0.3, 0.3, 0.3. Okay. Because if I am doing the same thing here, it's definitely not the same values. So this is why we're doing the reverse method. Oh shit, forgot to mention. Oh, I think we got a spam here. What's going on? I use power bench, yes. Forgot to also mention, does the voltage and current you provided also work with S19 and S19 Pro? Yes. Same thing if you got the 30 volt and 10 amps power supply unit, you can use. Let me take a look. So yeah, if you're using 30 volt and 10 amps, always take your amp to the maximum and it's gonna adjust itself. And if you're working on S19 regular, it's gonna be around 13.6, 13.8. And if you're working on S19 Pro, it's gonna be lower. It's gonna be around 12.8 that you will work. So yeah, there's that. So we got a little spam right here. So we're gonna take care of it. I don't know why people are doing that. It's messed up. Okay. So thing is, my resistance value seems fine. Now let's check the continuity. Oh, not the resistance, continuity. There you go. Okay. But thing is, I cannot really measure under it. Well, you see here, I don't have nothing, but doesn't mean that there's a problem here. Okay, there you go. So if you want to make sure that everything is alright with that, I try to have the same behavior from one board to another. So if I am here, I am measuring with the ground, continuity, no, continuity, yes, continuity, no, continuity, no. And if I'm measuring with another hashboard, just curious. Continuity, no, continuity, yes, no, and no. So it's pretty sure that it's supposed to be like that. Mm-hmm. Okay, so that's normal. And if I am measuring the voltage of that one too. They could have both of them the same problem, but I doubt it. 2.6, 3.6. Okay, so values. So now the values are the same as before, so that's great. Okay, resistance seems fine. I will change the last chip. That will be my second guess. First guess was the small part right here. Now it's not heating anymore, so that's a good thing, but maybe that part broke and then damaged the last chip. That would be a possibility too, because those two are linked together. So just to make sure it's not heating. Yeah, Julie, report this para, but anyway, thank you for telling me about the operation voltage and current. Thank you. And yeah, I don't really know how to make them go away. Signaler. Yes. Okay, I will try to delete them. There you go. If people were not doing this, I will try to concentrate more on the actual repair than just like people are spamming. I don't know why. Maybe but okay. Second try. That one. starting to melt. So you see all the heat that it takes and it's not even off. So maybe next time I will try to heat from under. Because the chip might still be good. Well, there you go. And now we'll use a little scrape, just a small tool to be sure that everything is nice and even. There you go. A little bit better. Because what's happening is that if you got too much of a bump here and you're applying another chip, that chip risks not to not be evenly spread and can have problem afterwards. Now let's try to go take a look if I have another chip, same thing as that one. So I have here 1362 AC. Let me check. I have here BB, so AC because S19 and S19J are not the same chip. So the architecture, physically, the chip are not the same. So let me take a look. AC. BAA. B. AA. I think I have. AA, AA. Let me check. I could take a chip from another Hashboard, but I just want to make sure that I got one that is working. AC, AC, AC. I got two here. Last one, AC. Nice. Got three of them. Yes, I was looking for AC chips,
Got it.
1362. I got three of them from Ahmad Desk, but if...
Just know we have some maybe here as well.
Oh, nice. Excellent.
Just a few seconds of time.
Mm-hmm. So AC, AC. Oh, this one, I was wrong. This one is a AA. Let's take a look if physically.
Je pense pas que tu mettrais.
No, 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 no. I will not use AA. If all the board is got AC chips, I will still use AC chips. So that one needs to be nice and clean. We had a spam on
On the leader?
yeah, yeah, yeah. I just deleted the messages, but there's some bot that want to join in.
Thank you for that.
No problem, man. Mm-hmm. Okay, so let's try to work that one. Do you still see the messages? Oh, he's gone.
What's that?
Do you still see the messages or they are deleted?
There is one I can still see from 69 mega. RAI help find you find perfect match.
Oh, really? But they're all deleted. Sorry. Hey, Crypto CHR. Long time no see. How's it going? All right. That one, let's clean the board a little bit. And for that one, I will heat from under. I think it's gonna be a little bit easier. So when you try to clean like I do right now, be very gentle. So you don't want to mess with the board. Okay. Now, because I'm heating from under, let's take a look. There you go. I want to preheat where I will put the chip. Yeah, should be fine. So when you're heating from under, you need to be well under the chip. So where you want to heat. Oh, it's starting. Getting there. So you see, I am on the other chip, so that's not a good thing. I was a little bit too far. So what I will do, because it's already preheat, I will finish on the upper side. There you go. So I think what you could try to do a good mix of the two. So you could try to start from under, and then when you see starting to melt, then you can go on the other side. But what happened is that I was heating more this one than the actual one that I wanted to do work. So yeah, that could happen. But everything seems fine. Out training repair on what's minor. Nice man. I know that you're making some training under bottom text. It depends. I am not always hitting from under. As you saw that one, I was hitting a little bit on the side. So this is the ancient chip. This is another one in just in case. So that one I will let it cool down a little bit. Okay. So I don't want to take it the same place that I was heating it. It will be too hot. There you go. So the first one that I had, let's see the problem. And maybe I can go try the two other one that I have because maybe it can be easier. And I didn't forget, I will show you how to do the jump. I'm gonna do it right now. Mhm. 06. Okay. So if I am testing, for example, right here, that one. So 1, 2, 3. Oh, interesting. If I'm trying, I'm gonna show you right after. 4.7 and 0. And 1.1. 0.7 and 1.1. Okay. You see, all the chips, all the domain have LDOs, 1.8, 0.8. If you want to measure from this side, you don't have, it's not one of the 5 testing points. So what you can do, if I am making power on, uh, I will go to one of those 2 capacitors. Same thing as 17 generation. If I am making play, I will go one side. So my ground right here, my positive. So this is my 0.8 and my 1.8 would be that side. But you see, it's 1.198. So something's going on. Something's definitely going on. Let's take a look. Those values are very strange. Very bizarre, bizarre. Oh, okay, that's why. I just so S19J Pro have different value on the LDOs. One of them is 0.8 and the other one is 1.2. So that's why. So this is how you're measuring it, but could be the 1.8 or the 1.2. The jumping method is the same thing. So when you want to jump, what you will do, you will use a wire that is connected. So just, you know, could be something like this. Just like a wire that have 2 sides. For example, my right side doesn't have any connection, so I would have 2 times that one, so it would connect. And what I would do, I will try to find my 1.8, or in that case 1.2. It's gonna be that side. So be careful when you're measuring, because this side, let me try to, there you go. So the interior side here it's 0.8, and that side is supposed to be 1.8, or in that case 1.2. And then I will use my jumper wire to go to the written signal right here. Or if, you know, like that. So that's how I would make the jump. Same thing with the 17 generation. I don't have one that I can show you, but yeah. So you're using your 1.8 or 1.2, so the highest LDO value, and then you're jumping with the same wire on the other side. That would be your return signal when you are making the test, and then it would show you a jump. That's how you're jumping signal. Most of the time, the jumping technique, I am using it when I have a hashboard that is, by example, that one is 126 chip, and if it's showing me 125, might be the last chip, but most of the time it's a chip, another chip way before that that is lacking something. And when you find that one with the jumping method, then you can change that one, and most of the time it's gonna go back to full Hashboard. Yeah, my pleasure. Hope it helps. Okay, let's test this one. What is it showing me? Voltage. Nice. So let's try to go straight to return signal. So earlier, the Hashboard that I took out a chip, turns out that it wasn't necessarily the problem because I thought it was 1.8, but seems to be 1.2 because of the LDO, because the strongest value that the chip is receiving is from the LDO. So if a chip is 1.8, like 17 gen, return signal would be 1.8. In that case, it's 1.2. Yeah, so you're always learning from your mistakes. Let's hope that the one that I put, the connection is fine, and we will try something else. So what I can check on that one? I will check the return signal until I don't have one. So let's try that straight in the middle here. So I have here 1.1. If I'm going here, and then here 0.8, 1.1, 1.1. Okay, but now I don't have enough voltage. Return signal seems fine on that one. Next, I will check the clock to see if the clock is going all the way. Now let's take a look at that one that I changed. So usually when I'm making my test, I'm using a cooling pad. I don't have one right now, but it's easier to diagnose. Point 3. Let's see diode, just 0.7, 0.7, 0.7. Yeah, seems fine. Hmm. So good thing my return signal is still the same, so the chip is well placed, but it was not the problem. If I am measuring a little bit further down here, same thing, same thing. Whoop, whoop. Here I am lacking a little bit. Okay, that one here is fine. So here I got 10 and going down. Let's see, LDO 1.3, it's LDO 2.0. Okay, let's take a look at the other one. Okay, all the domain, the return signal seems fine up to the first domain that I have an issue. Let's take a look under. Huh. Work has been done on that one. Ooh, there you go. Okay. So meanwhile, it's cooling off. Let's try another one. Yep, work has been done on that one. If I am taking a look, some resistance maybe has been changed or just moved, so I will take a look afterwards. Another one. Let's take a look at this one. So this one is supposed to have been repaired. The MOSFET were pretty problematic, so much that we put some heatsink on the MOSFETs here, and then some thermal glue. But let's see what the tester is gonna tell me. Un, deux, trois, quatre, cinq, 6, 4, 5, 6, 7, 8, 9, 10. A J Pro still. Okay, 13 J Pro. Let's go. Interesting. So I got power. My booster is working. And I got sign of life. So maybe a chip or a resistance before that could be LDO2. Let's be curious and take a look. So I got my drill right here. That one I will go. So you know, if you're working, can be any drill, but you need to be very careful with those. So power minimum, and then this is your sensibility. We will go a little bit less. Whoop, not that one. N'est pas nécessaire. I could just use any tools just to pry a little bit. These are well stuck. Oh, one here. I forgot that one. My mistake. Yep, that one was ready to run. One, two, three. Uh, you know what? I will need to take that one too, because it's right between. Hmm. Okay. So between those, here, Crypto Crag. Yo, man. Hey, man. All right, let's go in. S19J Pro right here. So let's clean that a little bit. When I told you last time, any tool, any phone tool would do the job. It's pretty useful. Because this thermal paste is quite recent, we might still use it. So I'm just cleaning the area that I will probably put some work on. Okay, this side seems fine. We can start, before anything, we can start diode value. So 1, 2, 3, stopping here. 7. Yeah, same thing from both sides. 7. 7. 7. Okay. 7. Let's choose that board. Mm-hmm. Survey 26. Yeah. So same thing, 13.6 volt. And now goes down to 60. What's happening with that one? Here, it's getting weaker. And my voltage is still the same. So starting from here, return signal 9, 1.2, return signal 0.6, 442. LDO, LDO is weak on that one. So might be the LDO. Let me go grab a marker. I try. Here, return signal is bizarre, but might be the LDO. Let's go under, click. So again, I'm always working with the same temperature, 470 and 55% of air. Yeah, all dirty because of the thermal paste. So yeah, S19, there's two complete different generation, S19, S19 Pro together, and then S19J, J Pro, and even I think S19A. Not the same values. Even while being here, I want to have a little bit more space. I'll try to work here. Already 3 p.m. It's, I think, 2 hours already. All right. I'll work a bit some more. I'll try to at least have one. I'll try to have this one. So let's see if I am zooming in for the LDO. I think I got some spare parts. Really, the guy that Ahmad that is working on a S19 those from those times. I think he ordered LDO and might be a good way to try. So anyway, let's put that one on the cooling pan and let's try the other one that I have. So two different board with LDO problems. So yeah. Mm-hmm. 126 and 0, complete 0. Huh. 15, 15, 13. I'll do 29. Might be the chip, might be the LDO. So maybe the first LDO that is giving 2000 instead of 1.2 might create problem with the 0.8 LDO. But what I will do, I will take out the first chip that is closest to them to see if it's the chip or the LDO. So let's take that one out. All right, let's go on the upper side now. It's preheated. Way easier if you start from under and then over it. Yep, should be fine. Okay, let it cool. Take the other one. Yeah. Let's try again for this one. Zoom, zoom, yes, there you go. Then going back, so the more you're doing it, the more you're getting habits, the more you're getting used to one technique. Let's try from the other side. Okay. Yeah, thermal paste is a real mess. All right. Now that one is too hot to test anything. Let's try a little bit more, like 15 minutes more, and then let's take a break. So this is chip. So these are the two chips that I just took off. There. It's warm, it's not hot. So let's try. Okay. Great. Let's see. Check. Will it work? Will it show me good value? Let's hope. 13.6. 1.2. 0.7. 0.8. Let's try to change that chip. So let's put back another one and see if the value will go back to 2000 instead of 1.2. And let's try to heat from under again. Where's my chip? Here. That one seems fine. Oh, but before that. No, let's try it right now. flare a little bit so it will be nice and flat. Seems a little bit high. What I mean by that is you see this side, you see the soldering a little bit more than on the other side, so it's a little bit smaller. I will test the diode values to see if everything is well connected. Otherwise, I will try to resolder it. So let's cool it down. Let's try this one here. Okay. Third one here. One 1.2. My LDO are fine. Same thing. Could be the chip, or it could be the LDO that when you put another chip again, it's getting a weakness. So next thing I will try to change the LDO afterwards. But I don't have many spare parts. I don't think I have any spare Hashboard like that. So I'm taking a little bit less chances. So yeah, let's try to put another one. And I think I have, yes, JPro chips. But those one are AA, not AC, so need to be careful. AA, right here. Oh, my goodness, place. So this is why eating from under sometimes is a little bit better. Seems right. What are you doing here? Hmm? Hmm. Okay, now let's try this one. Yeah, I think that's gonna conclude the repair for today. But I'm gonna test them right before, but I think it's gonna be enough for today and a little break. Okay, that's when I changed the first. Let's see. First thing, diode. Ooh, like that. If you want to see, some people told last time that they want to have a closer look. So this is the chip that I want to test and then that I changed. So diode value, reverse, positive, negative, and it's going like that. Clock. Yeah, value seems fine. Three, 4, 5, 6, 7. Oh, I do not have one with both of them. Ah, 0 chips. Sad. So 0.7 and 1.9. If I'm going to the other side, and 2.0. So I will try to change that one. Could try to measure resistance around. Could be it. Could be the resistance, could be something else. So let's try that one. We just received some new LDO parts. Maybe that can change something. I will keep it on the side because maybe that's not it. Might be just a small resistance too. So resistance seems technically fine. Could be that too. So I will try to change that one. Could also be another chip in the same domain. So I could try to just take out three of them and then start with the first one. Sorry. Second one and then second one. Still checking the behavior of the LDO and then the last one. But between taking out the three chips, putting them again, the changing the LDO seems to be faster and easier. Getting there. There you go. Okay. There you go. Yeah, that's some tricky soldering. Yeah. The one earlier was I think the trickiest one with the return signal chip. But yeah. Hey there. Here's some unrelated question. When I plug a S19 board into the ARC, the EEPROM read Antminer S19 675 9 and 13. Why does it read 9.957 H? Honestly, same thing here. It's 9.992, but most of the time when you plug Hashboards 17 generation, it will show the real value, but the S19 generation is not showing the real values. I don't know why, but we are on the same side. It's the same. I don't think it's really an issue, but yeah, same thing here. So don't really take care about that. Take care of the frequency and the voltage that is showing into your dashboard in the ARC tester. Other than that, don't really take care of the hash rate. When I connect T17, it said the actual TH value of the dashboard. It was like 14. Yeah, that makes sense. Those dashboard doesn't really make sense. I don't have a proper answer to that, so just keep to make your test. It's not an issue. It's the same thing here. So you see that one is showing me 545 megahertz and 9.992 TH second, and voltage is 13.6. So my frequency is fine, my voltage is fine, but the power of the dashboard, the TH is not the good one. By the way, before you go, I must say thank you. My pleasure. Honestly, I'm still learning to do better and better lives, and still, it's a little bit harder sometimes to try to explain what we are doing, meanwhile doing it, and because we are French Canadian, we still need to translate sometimes what we want to say, and we don't know anything, we don't know everything about the dashboard. We're still learning, same thing as you. So but thanks for being here, honestly, having some interaction, and don't hesitate to ask us questions. It means a lot, and also it means that we are not the only one that are working on those and have the same issues. So yeah, my pleasure. Well, I want to see the other dashboard if the chip, maybe it's going to be the exact same thing, and maybe two of them need to have LDO replaced. Maybe it was the chip on that one, maybe not, because that one seems to be another issue than the chip. So I changed the chip. Now I will change on that one. I just changed the LDO. Let's cool it down a little bit and wait. And if the issue is still here, if I have other resistance or capacitance here, I will need to check the values of those. And most of the time, by example, S17 Gen, the other dashboard that I was working on, the other live, if I can, I will just strip everything around here and just put new parts, just in case, instead of measuring them one by one. Or I could strip all the three uh, the three chips on those and see one by one. So that chip being the closest to the LDO, we'll start with that one. Is my LDO value still fine? If they are great, perfect, I will then put the other chip. When I put it here, is it the same behavior? And then going by dichotomy like that, and then going with the third. So now chip is changed, LDO is changed. Let's cool it down and try afterwards. Okay. Let's cool it. And let's see here, diode values. It's my So far the way the chip are welded is fine. So I don't think it's gonna be an issue. So if I'm going here, 1, 2, 3, like that. Nice, nice, nice. Looking forward to more of those. Also, I got MOSFET today. I got my MOSFET today, and I fixed my first MOSFET board. Very nice. So you see that one was the actual problem. It was MOSFETs. They were heating so much, so we put another heatsink. It's not really an official repair, but sometimes if the board if it is too damaged under, it can heat a little bit more, and then it can be, an alternative solution to the repair. It's not the best one because sometimes it can work for a while and then break. But for that while, could be 10 days, could be 100 days. And if it's mining for 100 days, it's fine. But then it's harder and harder to repair those. So if you've seen some of those, these were completely burned out. But as I said, you're not the only one on those. But yeah, we will do more S19 lives when we have the chance, and also when we have some question that you're asking us, we can answer them on lives. I think it's a better way of interaction if you got any more question about those. Looking forward. Thank you, man. You're in Montreal too. Oh yeah, I remember. So you are on the Discord channel, so that's perfect. Last question. I saw you guys put eating on MOSFET when replaced. You recommend this as a general practice. So I just answer it without reading the question. So, I, you know, it's not an official repair, but even Bitmain is doing it sometimes. So we will recommend it as almost as a last resort. It can work a while. Sometimes it can break straight into the machine, and if it's happening, I think your board will have a hard time to get repaired again. And also because all of the thermal glue, it will be way harder to work on those afterwards. So I don't even want to see under those what's going on. But you see, MOSFET seems fine on that one. So I got my voltage, I got my booster values, but if there's something going on under it, I don't want to work on that one again. So, if you receive one of them repaired on your center, you know that somebody else has worked on that one and it's going to be a harder repair afterwards. Let's try. But yeah, even if there's no big victory on those dashboards, it's a small step to learning. I learned about those that the LDO wasn't 1.8. I'm so used to that. S19, S19 Pro was 1.8, all 17 generation. L3 Plus, S9, all 1.8 and 0.8. Those one is 1.2. So the behavior is not the same. And because of that, I changed one chip that it wasn't necessary. But we learn from our mistakes. That one, okay. See. Ooh, better and better. So that one wasn't the LDO. That one was the chip. 1.2. And if I'm going, I will need to clean it a little bit. So 78. Nice. So it's not a complete victory, but it's like 50-50. It's still alive, and I got a signal elsewhere. And also, it's a signal that is far away from the booster. So that would mean that there's no real problem here still. But if I'm going last one before, it's gonna be around here. Yeah, we'll need to clean all those. So the first one wasn't the chip, might be the LDO. I will try it out. That one, I wanted to make sure, so I took out the chip because the LDO wasn't showing me the good values. I took it out. LDO values were fine. I changed the chip for another one, and now it seems fine. But there's another problem elsewhere now. 1, 2, 3, 4, 5, 6. So here, 1.2, 1.2, 1.2, 1.2. Okay. Return signal is fine. Let's see here. 1.2, 1, 0.8. So that's fine. So that one. Let's see. Clock. Oh, so stupid. I am not in voltage. Still 1.2, 1.2, 0.9, 1.2, 1.2, 1.2. Clock, 1.2. Oh, clock here, I got 0. And then minus value. Ooh. Let's take a look again at the diode. So it's between those two last. So you see it's stopping at 77, but it doesn't mean that it's going to be 78. Might be the entry of 77 is fine, but the out, so the between 76 and 77 it's fine, but between 77 and 78 it's gonna there will be a problem. So let's see diode values again from one side. And remember that your diode value might be different because of the heat. Clock. Clock is fine. So the chip is well placed. Let's take a look at the other one. 6, 7. Okay, so the chip is well placed. So the connection is fine because diode is indicating the quality of the connection. Doesn't actually show if the chip is good. You can have a good connection, but a faulty chip. Let's close that. Now, let's do some overtime. It's always more encouraging when you got some life out of your dashboard. Uh, Let me just grab something real quick. You saw it? Hehe. Okay. So while we're here, general practice. Yeah. So perfect. So if you're still here, why not continuing it a little bit further? So I will try that chip. I will take out the heat sinks of 77, 78, and I will start with 77 because the clock signal wasn't good. So yeah. Joey? Oh, yeah. Excellent. So that was one of my coworker, Nick. Nick or Burning Whisper that is on the Discord channel. So this is one of the guys that is working in the warehouse that is testing all the machines. I think he's shy a little bit. Next time he will come by, I will want him to say hello, so you can put a face on people that are writing. And he is one of the guys that is cleaning the Hashboard, and he's doing a fantastic job. We cannot work on those one if they are not well cleaned. It's one part of the process that is super important. So never neglect a good cleaning. Sometimes you can even save the board. So here. Hmm. So I just took each thing from 77, 78 because I will probably work on the other one. But I will start with 77 because I don't know if I said it. Yeah, clock was 0 and 78 was minus something. I could do 78, but maybe its signal is being eaten by 77. So yeah, and let's take a look if there's no any if there's not any resistance that are gone. Everything seems fine. So let's take 77 out. And this is AA. Mm-hmm. There you go. All right. Okay, AA chip. Once I put that one on, I will check the other hashboard with the LDO. Yeah, good, 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 good. Let's see if it's well placed. There you go. So a little solder ball has been formed on the down left side, but it's fine. There you go. And we're not speaking about it anymore. That's good. Okay. Let it cool. Let's take a look at the other hashboard. Ooh, that one is hot. Okay. So I want to take a look directly under because that's the part that I changed. And I want to see if something bad's gonna happen because if it's not a compatible LDO, because we didn't find the exact same one, yeah, that could be problematic. That, where's my spike? Here. Still 0.6. 1.9. 1.40. 2.2. So it could be something else. Could be another chip. Could be a resistance or capacitance around. So what I will do with that one, I will put back the previous LDO because that one seems fine. And I will take out all the chips of the domain and start one by one because I do not have this exactly the same resistance. Or maybe those resistance and capacitance, I could measure them and try to find them on scavenge hashboard 17 generation because I don't have 19 generation. So that one would be the next step that I will do. So it's gonna be for another time. And let's take a look at this one. It's still a little bit too hot. Let it cool down a little bit more, 1 or 2 minutes, and try the other hashboard that I tried earlier. That one. Good. Let's take a look. I took notes. I took zero ASIC notes, but I don't remember what was the issue because I think that one was too hot. Return signal was fine, but let's take a look at the clock value. So here, oh, return signal is completely out. Why? Oh, do I have booster value? Yeah. Do I have return signal? Yeah. Do I have return signal? Whoop. Do I have return signal here? Yes. Do I have here? Yes. Yes. Return signal is fine. But starting from here, I got completely different values. Huh. Okay. Are my LDO okay? 0.8, 1.2, 1.2, 0.8, 0.8, 1.2, and on the other side 0.8. And then here's my problem. LDO is fine on that domain because on the other side I got values, but here I do not. So let's take a look. Let's take a closer look. I'm going to show you what I did here. Wonderful. Let's do that again. So here, if I'm measuring here 0.8, 1.2, 1.2, 0.8. Here on this side, 0.8, 1.2. Here, complete 0. And it's changing so that maybe the capacitor is completely broke off, but might be okay. No. And if I'm measuring here, is that one great? LDO is fine on this one. Oh, I'll measure here. LDO on the entry side is fine. On the outside, it's fine. Clock signal. 1.2, 1.2, and here there's some variation. So that would be between those two. Is that chip causing problem to the other one? I could start with that capacitor because that capacitor was showing me variation of the 1.2 voltage. The other one is fine. And also here I get my values, and those boards, the LDO are Where are they? So this one, LDO is on that side, but that will mean that this one, LDO is on the other side. So LDO is fine. It's just on the last one. So yeah, as I said, that one I will start with that part. I will change it. If it's still the same thing, I could either change this one because the clock signal. Oh, I didn't measure the clock signal. I measured TX. Again, a question of habit. This, this, that. But the TX wasn't constant. So if I want to have clock signal 1.2, clock signal is going to be this one, and it's 1.72. And then if I'm going here, clock signal 0.5. Whoop. And then it's getting weaker and weaker. So one of those two chips or the capacitor will need to be changed. Let's do that right after, but for another time. Let's test for now the board that has the most sign of life here. Hi, Leandro. I have an S19J that chips 126 is oscillating. I have already measured the signal. The BI is varying. Curious thing is that I don't see the peak of this model. It's usually close to the data connector. You don't see the peak. Man, the peak is right here on those S19J. S19J and J Pro. That's the peak. That's the EEPROM memory. So I'm gonna point you. That's the peak. That's the EEPROM memory right here. Here's your I/O port. So yeah, and your I/O port should send about 3.3 volt, 3.2 volt of signal. I didn't read the rest. Just think that I don't see the model. The chip is oscillating. Maybe you could be more specific about that one. Is it the tester? So what kind of tester are you using? Is your if it's an ARC tester, is it, by example, showing 125 and then 126, or is your values of the 126 making some oscillation? So that will need to be more precise. You remove the tree 24, 25, 26 and put new defect continues. I check resistance and capacitance and LDO. Everything is okay. I don't know what to do. But there's a tip. Suspect it's a manufacturing defect since the new board is not used. Yeah, mine doesn't have this pay. Oh, sure, maybe it's a completely another model. Try to check on the other side. Maybe it might be around here. I don't know if, yeah, could be on that side. All the dashboard have picks, so should be on that one too. Um, but if you got because you changed the tree last, but the last one is oscillating, might be completely another chip way before that, and then you could use the jumping method. So you're jumping between the LDO, the more powerful LDO could be 1.8, or in that case of S19J Pro 1.2, you're jumping between the capacitor and the return signal. So just, I don't know if you were here before. So here you got, for example, capacitor 0.8, and then that one is 1.2. So I will jump that side, and then the return signal testing point with the same cable. So that way it will make a jump. If I got that board that is working, that is giving me some value, I will try to show it to you. The test it says as S19J Pro, but I don't see pick on the board. But the effect is not pick. I don't think it's the pick, because if it would be pick problem, you wouldn't have any values actually, because your pick is your communication between the hashboard and the control board of your miner. So if you got a problem right from the start, you wouldn't have all your good values. So this is why jumping method might be interesting. Okay, let's try. This board, I changed 77. Before that, diode values. Is my chip well placed? Yep, yep. I just check around 2 or 3 of them just to be a little bit quicker. And also S19J or J Pro might have new revision. I've seen that on L3 Plus. So L3 Plus had a revision 1.4.1, 1.5.1, 1.6.1, and many other ones. And some part were different. Values are the same, but some part were different. So that could be the same case with J Pro. Okay, let's power up this bad boy. Yo, what do you need? Yeah, sure. It's empty. Take some from my desk if you want. No, 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 no. Something's going on here. Oh, it's still at the same point, but why it's still 77 and it's not place at the same, it's not at the same place? Maybe because I didn't click specifically to S19J Pro. So if I'm going here, my value were around here. So your arc tester is still detecting the signal. That's why. So it's still the same value. Still the same thing. Everything is working fine. But it's a J Pro. So it's just a little bit better. And this is why the signal is different. Oh, okay. But what that means is that I changed the bad one. So probably I changed 94, 95. I changed 92 instead of the real 77. Well, at least my signal are exactly the same. But now let's take a look at. This is why I prefer to have my hashboard. If I could turn it 45 degrees, I will have it straight in front of me, and it will be better for diagnosis. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Hmm. Okay, here. 12, 12. Okay, clock signal 2 and 4. Okay, that one is weak. Clock. That one is better. Let's test. LDO. LDO values are fine so far. LDO is fine. So the it's a healthy domain, but I got a weak value starting from here. Is it my clock resistance? So same thing, I will start maybe with 77. Let's take out that, that. Clock is fine. Clock is fine. So my clock was weak, but might be the chip. Reset. Yep. So quality of the connection is fine, but the chip might be problematic. But 76 is good. So the value of my chip of the chip 76 was a little bit strange, maybe because of the chip 77. So I will still do 77. I was supposed to do 77, so I will still keep that idea. So a little bit more of overtime, that one doesn't count. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. That one. But because I'm working on the same domain, I will take out all the resistance. Because I said JPro don't see the pick, but the fake is not pick. I have Telegram. My signal is oscillating. I remove chip. Is OK signal already changed the three domains? The three chips of the domains, you mean? Or you changed three domains? If it's possible to send us a video, something, or at least picture, because I don't really see what you mean by oscillating. Maybe you got an oscilloscope and your value are oscillating, but I want to see on the tester what signal you have. If you have an ARC tester, it's going to be way easier for me or anybody that will answer to you, because we are most of the time working with ARC tester. It's going to show you a visual, but maybe if you got another one, maybe we are working with Pico. So Pico BT, that is a great one too. Didn't try that one yet, but good alternative, because I want to see what you mean by oscillating. So here, okay. Huh, 77. So it was a way longer life than expected, but you know, if you still got question and you're listening and you're learning, it's my pleasure. Okay, let's start with that. A little bit closer, closer. Otherwise I might burn the disk. Whoop! So that one's gonna be harder. We'll go straight from the top. Let's see. M30S. Oh, but it's a Watts miner. Watts miner is another tester. Um, so the same company are making Watts miner tester. Might be on the list. I don't remember them by heart. Maybe we will need to check that after. Huh. I just saw on the list S19 J Pro no pick. So maybe there's no pick on that one after all. Didn't touch that one yet. Okay, let's try one other chip.
Oh, bonjour Joe.
Hey man, how's it going?
Ça va?
Ça va toi?
Ça va? Est-ce que Joe est là?
Joe il est en meeting en ce moment.
Ah, question pour toi.
Mhm.
J'ai ce S19
S19.
qui est un bolt il marche plus, mais j'ai l'impression que je sais déjà c'est quoi le problème si tu ça directement. Ouais, hein? C'était comme je l'ai vu, puis j'étais comme ok, je suis pas mal sûr que c'est ça qui a pété, genre.
Si c'est pas le problème, c'en est un.
Parce qu'il marchait fort, tout était bien.
And then it exploded?
De nulle part. J'étais comme ok, c'est quoi le problème? Là, je le sors, je vois ça, je suis comme shit.
Juste à dire, je fais un live en ce moment. So I'm showing them. So one of my colleagues showed me S19 Pro or J Pro.
J Pro.
Yeah, J Pro that was working fine, and then in the machine the MOSFET completely exploded. So if it's not the problem, might be a problem. Yeah. T'as-tu déjà travaillé sur eux autres?
Non.
T'as déjà travaillé sur eux autres? Ok. Ouais, man. Ça, tu le testais dans le test room, puis il a sauté? C'est
Non,
ça.
non, ça c'était à la mine.
Ça, c'était à la mienne. Bon. Écoute, mets ça dans le système, check avec
Ouais,
Nick pour que
c'est ça
tout
que je
soit dans
voulais
le
demander à
système.
Joe, là.
Euh,
Que je voulais voir, je voulais demander à Joe comme si c'était ce que ça avait de l'air. J'étais comme ça a pas
il y
l'air
en a,
normal de
non,
juste.
non, il y en a plein que c'est comme ça.
Ah ouais?
Ouais, ouais.
Eh man, ça va? Attends. Ouais.
Yep.
Je fais la machine.
So sorry for this interruption. Yeah, one of my colleagues just bring S19J Pro Hashboard that the MOSFET are completely gone. So that would be another repair. Okay, let's change that one. That one, I will try to. Here. So we'll heat from above, but not the chip right now because I don't want to apply too much heat. Getting better and better. So now that it's preheat, I could put the chip. So the third pin got a little bit more solder, but I don't think it's going to be enough for any shorter bridge. So that should be fine. It might be a little bit bigger than expected. So let's just take it off or spread it with the others. There you go. Beautiful. Update Arc firmware. Yeah. So Jonathan just answered your question. So the what's minor, you can do the update, and I think it's gonna be here. So what I could do in the meantime, let's work on the other one, zero ASIC. Oh yeah. So why not? We're not working on that one that had between those two that had a problem. I do not have this capacitor. And there's been some work on this one already. LDO has been changed. So I know that on 17 gen, you can measure the total resistance of the domain with the LDO. So if I got some LDO here, I could try to measure some values. 19, 21. I don't know yet how to measure them properly, and also it's all under the heat sinks. Let's take a look on the other side. $180, 0.4, 0.4, and that one is varying. So if I'm trying yet again, so I got a resistance of the LDO 0.8 of around 0.440, by example, on the 17th generation S17 Plus from what I've measured. You can take a look at the other live that I did last time, live number 12. You can measure all the resistance of the LDO 0.8 of all the domain, and it was about 0.880, something like this. So that one should be around 0.440. So if I'm doing measurements here, that could be another trick. If I'm, by example, measuring that one, nope, 0.400, still within values, still within values. Oh, that one is a little bit higher, 0.5, 5, 5. 387. Yeah, still need to work on that technique for those boards. Okay, around around 400. That one is a little bit higher. Hmm. If I'm trying diode, so I just want to have the best kind of value possible because I'm hesitating between those two. So which ones should I start? I could just jump in and replace one, but if I got an indication that one of them is defect, I would use it. 300, 284, 455, 455, 300, and then no values. I'll change that capacitor because I don't have any values on that one. Yo. Uh, I can take that one. I can take those ones. Oh, it's just it's already what, almost 3 hours on those ones. Well, If some people want me to take out those completely burned MOSFETs, so just let me know. Otherwise, I will finish with those one. It's gonna be for another time because it's already almost 2, 3 hours. I don't remember. I tried to see 3 hours and a half. So yeah, but when you're working on those ones, you don't really see the time passing by. Capacitance on that one. Let me take a look if I got any scavenge, any board that I could scavenge. Or what I could do, because you cannot measure the values of of a capacitor if you don't have the proper tool, and that happens that we don't. It's another kind of multimeter, so I will just try to have those measured. You can measure them on the side once it's out. Or even better than that, let me just make some research real quick on S19J Pro and those small capacitors. One chip. Resistance, resistance. Cannot find the proper value. U273. U273. No. So what I will do, I will measure those on the side. But before that, before that, I really want to test that one. So let's see if that chip is great. Seems fine. And don't forget JPro this time. Getting there, getting there. Now, 89 and around 90. So maybe, meanwhile, trying to repair that side, one of them has unsoldered. Let's measure a bit. Return signal is fine. LDO is great. Let's take a look at the clock then. 0.2, 0.4. But maybe now I just got a voltage of 8 instead of 13. So it's gonna be around that. That one, what I will do to have the good values, I will take the capacitors out. And I will do the same on another board. On the same board but on another chip. I will take out that capacitor to measure the values if they are the same. Doing MOSFET right now. All the pads I had prepared are doing the job for right now. Nice, exactly, but it works. Yeah, if it works, that's the good stuff. So maybe I can try to take them out after a while on the other hashboard that I just received. Let those capacitors cool down a bit. And let's take a look at this bad boy that I just received. So that one was mining and all of a sudden not working anymore. So yeah, Exactly, it's very tedious, so this is why I'm gonna try to maybe you learn something about my technique. I don't know. I don't really have technique. I'm going by experience. The more you're doing them, and I'm trying to gauge a little bit how these are damaged, and most importantly, how the hashboard is damaged, because that's what you want to say. You can change the MOSFET, but you cannot change the entire hashboard, you know? So that one's gonna be on this side. Oh, they smell the burn. I've been taking them out with the heatsink on from under. Yeah, could try that too, because here I don't want to burn that part. Oh my god, they smell bad. They smell really burned out. Okay, so let's try that. We'll go grab something better. Master MOSFET. Let's try that one.
On your video, tell him, okay, call is the Lagna.
Not yet. Okay. The side opposite to IO port I always want to peel off. Opposite to the IO port. Oh, you mean the side under? Yeah. These are very messed up. So I will use this to try to work on those. I will use a huge amount of flux. Let's try. Oh, just before that, I want to be a little bit closer. I want to see what I'm doing. And I will go max power. I will go 450 and 75% of air. Take a deep breath. Don't breathe those. But you know, just to be sure, I will take out those capacitors right here because I do not want to burn them. These are in a really good state still. And I want some place to work. Move, move, move. Fuck. One. Well, two. Okay. Let's continue on my MOSFETs. Now let's try on the upper side now that I got more space. Try some. Tabarnak, il veut pas partir. I don't want to damage the pin. Okay. Woo. Let's see under. Wow. Completely fusion with that one. Mm. Mm. Hmm. You don't say. Struggle is very real. That's a real life situation. Oh my god, this is so damaged. Mm. You know, there's that part. So I just hope, yeah, that one is completely burned out. Okay, at least my four pins are not damaged. So on a second inspection, I could try to take off all that copper here that seems to have fusion under here. Okay, one done. One here melting is fine. 2, 3, 4. And then let's go on the other side. The best I think would be trying to hit them from both sides at the same time. Woo! And that is a MOSFET. So remember when I said it's almost like a heart surgery, so you need to be very careful. There you go. No, this is what I really want to save. So the all those small that's right here. I want to try to save them, but all the here, all the PCB is completely gone. It's completely melted. So meanwhile, I still have heat. I will try to go on the next one. Okay, just wait a few seconds. I'm gonna get something better, better tool. Man, Ouais, je pense pas. Ben, je pourrais les enlever. Je pourrais essayer de les enlever tant qu'à ça, là. Mais man, c'est MOSFET. Et tarnac de calice de MOSFET. Mm. So, since I'm starting to doing them, I was not breathing. I was breathing on the side, so let's be a little bit better prepared. Mm. I am full equipment. Let's go.
Mm. 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 Is there at least, for some reason, I find the last leg, like the one toward the inside of the bar, the most delicate, always seems to rip.
Oh,
Um, mm. Okay, I'm gonna finish that, and I'm gonna explain you after. But yeah, you need those. Mm, of course, it's toxic. So you want to scrape them a little bit, so your threads are nice and shiny. I see one, two, number four, but number three is harder. There you go. Now number four is better. Oh! Woo! Come right off. Nice. That one is nice. Okay. Good. C'est bon? Turn. Yes. Nick. Nick. Amène-moi les plus petits scalpels, s'il te plaît. Ils sont pas sur le bureau, Ahmed. Ou dans le petit kit qui est dans les tablettes. Merci. Ouais. Merci. Parfait. Turn un peu. Woo! Mm. 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 Ah oui? Combien de temps t'as fait? 5 hours? And how much time do we have now? So they just bring me that board last minute, and I was like, okay, maybe I can show some. MOSFET, man, MOSFET. Oh yeah, the worst, the best and the worst. Okay, almost, almost. Almost, almost. Tabarnak! Woo! Oh yeah, okay. It's not the cleanest, but last one. Mm. 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 Nope. And last one, last one. Woo! Mm. Oh, that was fast. Okay. Mm. 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 That one is easier. There we go. Woo! Oh! Mm.
Nice. So no pins are broken. So that's really a great thing. And this is what it looks like. Seems doable. So, whoop, we got some spam. It's nearly. There you go. Took care. Wait, that flux fume are toxic. Yep, flux fume is toxic. So what's happening most of the time? If you're breathing flux, there's not really like permanent damage or something, but on the long term you could have some asthma symptoms. So that could happen, or you could have your eyes irritated and your les poumons, lungs, like irritated lungs, and you could have asthma symptoms, less breathe, or you're coughing often. But most of the time, what you could do when that's happening, you can just stop breathing that stuff for like almost 2 or 3 weeks, and everything should be back to normal. But if you still have symptoms after 3 weeks, maybe you should see someone. But I don't suggest to breathe that thing much often. I know. When you're a technician and you're breathing that stuff, sometimes it got that good smells like maple smell, or even mint smell that you can have. But don't breathe that too much, otherwise you will be flux like us, and you will do crazy stuff. Friday. So what I will do, I will try just to clean a little bit for the time being. Because all those sections needs to be nice and flat. Before putting any other MOSFETs. But the heaviest part is done. What I could try to do is applying some easy melt soldering, low melt, low melt soldering. Do you have some? I will try that. Yes. Merci. Ah ouais. Mm-hmm. Same thing as the one that I had. Okay, let's try that. So this is some low melt solder. Maybe that could ease to take off all that fusion soldering that is still remaining. Hi man, take care. My pleasure. Uh, just clean what's remaining here, and yeah, that will be it. Hmm? Son? Oh, because I didn't thought about that one. I could try. Mm, ouais. Yeah, I will try that one. Mm, yeah, I didn't thought about that one. I will try that right now. So using soldering iron instead of soldering air because most of the job with air solder is done. So I will try with that one. Big iron, 450 degrees. Some more low melt. Wow, what a good idea. So, sometimes you just need to have a second view or thinking out of the box. Because it was so obvious for me that I was heating too much with air that that I needed to continue with that. But at this point, I just need to clean. Maybe bigger soldering wick bread would be a good thing, but that one is making a great job. Mhm. Okay, this is enough for that one. Ouais. It's cleaning, but it's very well fusion. That one is a little bit bumpy still. It was, yeah. Let's try to scrape it later. That one's it's gonna be a little bit better. Cannot be worse than it was. Mm-hmm. So if worst come to worst, we can just apply a big metallic pads on them and shorting. For example, we can take a part like that, that metallic part, and take it all the way and just connect the MOSFETs. It's really not the best practice, but worst come to worst, that could be an alternative, and even Bitmain is doing it sometimes. So yeah. Whew, it's crazy. That one. Okay, that one is great. Yeah, it's very tedious, so it's one of the hardest work on the hashboard when it's completely burned and you try to uh, to make it in a good working state. Okay. This. Hmm. That's way better than before. Okay, so this is what it looks like after. Way better than before, and seems much more possible to work on that one with and apply new MOSFETs. So yeah, we'll clean all the zones, all the zone of that one. So you know, with I will reapply those two capacitors that I took off, clean all that flux. But before that, I will try to put back new MOSFETs. Oh, I think I don't have any more batteries. Click. Uh, maybe not right now because it's still a little bit bumpy, so I don't think my MOSFET will be completely flat. So I will work a little bit more on those ones. But yeah, let's take a break for now. I think it was quite a good live. So this is what looks like a day with S19. So you can have a little bit of pretty much everything. Some of them are going toward victory. Some other are a little bit harder to work on. So but the important thing is do not discourage yourself. The more that you're working on it, the more you will know them, and it can help with other kind of boards too. So if you got a J or J Pro, some of them are similar, but you know, you're every time you are learning. So yeah, this was Raz from Decentral. So you can join us in our Discord or any other type of channel that we have, and uh, and I wish you a great day and see you next time on the next live that we will do.